So hello, I'm Vanessa Speight from the University of Sheffield, and I'm here representing the Environmental and Water Resource Institute WDSA History Project. So this project is documenting the history of water distribution system analysis through a series of interviews with various engineers and researchers and others who've been working in water distribution. So today I'm very happy to be here with Michèle Prévost and Marie-Claude Besner from École Polytechnique in Montreal and the City of Montreal. So I'm going to start with Michèle and ask you how you got interested in water distribution systems when you first started your studies.
I got interested because I was into biostability studies for process. And once you finish your PhD, you want to figure out if it works in the distribution system. So I got involved in distribution systems to kind of figure out if it worked and the system stayed stable, really. And from there on, it just went on and on for 25 years, looking at different aspects of water quality in the system.
That's interesting. And Marie-Claude?
Well, basically, when I started my master degree back in 1997, I believe, and so Michèle hired me, and we had this project looking for, trying to understand why coliform occurrences, the reasons for why coliforms were occurring, were detected in the distribution system. And at that my task was to develop some sort of tool. And so we went on with developing what was called eventually the integrated approach.
What a title.
Yeah. And well, in fact, it combined the use of hydraulic modeling, and also it was some sort of geographic interface showing water quality results, hydraulics results, and also data from water utilities about having pipe repairs, flushing activities, and we were combining all these data to try to understand changes in water quality. So basically this is how it started, and it then led to, several following work on that topic as well.
Because you really found we couldn't explain.
Well, and we also, yes, and we also found that the previous explanation related to regrowth was not the only reason, because in some cases we found out that repairs were actually the cause of the occurrences. So this led to...
When Marie-Claude came, we were just out of the PIMA study, which was a health impact study showing the impact of drinking water on the rate of gastrointestinal illnesses. And I was coming from the biostability field. I wanted to show something with residence time, and I had biofilm monitors throughout the system. None of that came through. What did come through was the state of the piping in the areas where more illness was seen, and that was the start of the big intrusion. And when Marie-Claude started, we're trying to figure out if are breaks, are repairs the cause of it, or is it intrusion, or what is causing the measured twice, two studies, a repeat study and a basic study. People were ill, children were ill, especially children, so it was really looking at the cause. And then using the tools was fine. It never worked out for biofilm, but it really worked well for other aspects of the work. Yeah.
But then you've gone on to look at all sorts of water quality aspects. Can you talk a little bit about some of the journey that was?
Yeah, from that health study, we got, I guess, focused for 15 years or so on understanding the role of intrusion on illness. And I tend to do work that brings back this really amazing work that's done on the hydraulic modeling side of things to try to bring it back to a health outcome. If it doesn't have a health outcome, it's a really interesting field, but to me it's less interesting. I'm funded by utilities. Utilities want to know what to do to prevent illness or to be compliant, like the coliform project. So yeah, from there we really dwelled into repairs, how to repair intrusion. We still are doing work presented at this conference, trying to really understand if we can improve this risk analysis and how can utilities use it to react to events that could produce ingress in a efficient way while protecting the population. So.
And then you worked at the US EPA on the intrusion modeling, and did that give you a new perspective on the policy side of things too?
Well, yeah, but it gave me more the follow-up of the project, because I mean, at EPA and as well with the work of Marc Le Chevalier, we were focusing on transient pressure, the risk of intrusion associated to very short low pressure. But then from my work at EPA, the next step I wanted to study was what's the effect of long duration loss of pressure. And by then we found, I mean, we knew, but we realized that the use of EPNet, for example, was not totally adequate to do this type of work. So this, when I came back to Polytechnic afterwards, I mean, I wanted to go more into that topic, and that's why the students that have followed afterward are working on that. So this was my main finding from my work at EPA.
I find these extended periods of pressure deficient conditions are perhaps more common that we want to acknowledge.
Yeah.
Yes.
And if you look at another student work with Marie-Claude, Gabrielle Bachar showed that the valve chamber orifices were a big risk. It was an obvious one, but nobody really thought about it. But these extended periods of pressure deficient conditions that are more common than we thought are probably more important in terms of risk than these transients, which have been shown to be very short duration, and except for some of the pathogens that are resistant to chlorine, not a big deal really. You can figure it out if you have some residual in the system. So it's that's basically where we still are with the sustained. I would think that this type of work has more relevance to many other systems across the world, because we live in a very rich country with distribution systems that are pretty well maintained.
Yeah.
But in many countries, pressure is not maintained most of the time, so these issues will be relevant to them as well. So.
But now, Michèle, you've also become really interested in the building plumbing and the household plumbing. So what are you learning in that side of things?
Well, I've gotten into plumbing because of lead like everybody else, but now I'm into Legionella and large building acquired infections. I think it's the next frontier for this group as well. All the nice tools we're putting together have now to be pushed into the large building field. All the information that you've developed and others on materials, disinfectants, now needs to be pushed to that level. It is now very clear that the risk is not mainly at the distribution system level, but it gets amplified at the building level, whether it is metals, whether it is bacteria. We need to focus there now. So I hope this group will move there. I'm seeing a lot of clever demand analysis. I'm not seeing quality yet here, but I hope it will get there in the next few years, because that's where the health outcomes are, and it's important to have the tools to understand how to design our new buildings with these tools as well.
So you've both done a lot of research that's very applied and working directly with utilities, and now Marie-Claude has moved to working for a utility.
Yeah.
Do you think that's helped your results, or how has that affected your career versus some quite theoretical people who do modeling without that direct contact?
I hold an insert chair, industrial insert chair. I could never be theoretical because my funding is a funding agency, insert, and utilities. So I'm always at the frontier. Sometimes I'd like to get lost in biofilm studies, but I can't. So and I think the fact that the students go to utilities and to academia, depending on which ones you consider, it gives you a reality check. It also gives you feedback on what you thought was a great idea or great project, but never turned out to be used as much as you would like so. So this link is important.
Yes, and being on the utility side now, I mean, we have to evaluate this collaboration. Every
year.
Yeah, we put money, so we have to see, what are the benefits of it. And so this is like it's a very practical partnership. Yeah.
Looking at the sustained low pressure as an example, the question I get asked is 20 psi a good reference number? Could we get away with 10? So that brings us back to modeling, it brings us back to quality risks. And so it always has to come back to, we can't get lost too long. We come back with an answer, even if it's not perfect or complete, but to the best of what we can do at that point. And it cannot take 5 years to come back. It needs to be faster than that. So that's applied science, isn't it?
Yeah. But then the challenge is when you're trying to help run an active system and things go wrong.
Different world.
Your research has to be flexible in that
Yes.
case.
Yeah, and it has to be, I mean, it's like we need to talk, you know, because as Michèle said, she may have some very good idea, but then it has to fit at the same time, because we understand that the work she does, I mean, it has to be published, it's research and it's science, but at the same time, it has to answer our questions, you know.
Yeah.
So.
To be able to secure that support, and it's also a lot of fun for the students because they tend to see what they did. When I finished my PhD 2 years after they built the first stage BAC filters, I thought, oh, my research was very useful. So if the students that come out need to be practical in part of their PhDs, it also makes them more valuable, I would think, for hiring by the utilities, and that's good.
Yeah, and in from my own experience, I mean, I went to the field when I did my PhD at repair sites, you know, to evaluate the conditions and, you know, pathogens in soil and water and the role, the effect of the actions that was going on. And even today, I'm still writing procedures for our people, you know,
to
give them that these are the good practices that you should follow, and please follow them because it's important. So yeah, I have to translate, you know, what I've done into practical things.
Yeah, no, that's a really good comment. And I wonder too, with the building work, if we need to be talking more with plumbers, house builders, lots of the other professions who traditionally we don't necessarily talk to. Do you
I see
get
the
a chance to talk
interface
to
with
them?
all this. Yeah, I work in hospitals, several hospitals, and my primary source of information on the system is the head plumber. And the older the better, because he knows about the old plumbing in the building as well. So yeah, it is important. But I see the match now with this detailed demand push for all the modeling. You know, the water quality modeling is not perfect in the end. The distribution system, you discussed this today, but it's been covered. So we need to get better at predicting what goes in the building, and then to interface it with how water is used in the building. So that's a natural outgrow of where we are at you know, really modeling demand very well. Now we have to integrate the building demand and how we design these systems to keep them safe, and also energy and water conservation good. So
where do you see the field is going?
There.
It's going to the buildings?
Well, I see the field, obviously, energy optimization, resilient robustness. These are all really, really important aspects of systems.
Yeah,
I'm not involved
modeling.
in that part, but it is so important. I can see it from my point of view. If you want to link all of this really important work to health outcomes, you have to get to the predicting water quality at the end of the system and in the building. That's where I see my contribution of my thought to the future, but obviously there are many other important issues with infrastructure that need to be assessed.
Yeah, and on an operational point of view, I mean, real-time information, either it be modeling or sensors or things like that, I think we have to go to that point. But I mean, there's still a lot of work, you know, before we are at the best, you know, the best situation. I mean, there is still some work to do to go there, but at some point we will. So.
Okay. Do you have any other things you want to add?
No.
Nope.
Well,
Thank
thanks
you.
for
Thank you.
doing it.